We are now continuing with this Math 137 test number 4 review problems. We're at number 6. We're still working on problems involving law of sine and cosine. Number 6, side A is 90. The length of side B is 70. And the length of side C is 40. So this triangle, we can say they give us the three sides. When that happens, you have to use law of cosines. You can actually choose to figure out whichever angle you want to start. I'll just choose angle A first. So the equation to find angle A from the law of cosines is A squared equals B squared plus C squared minus 2BC times the cosine of A. On everything but angle A, so I can use this equation to determine angle A. So I'll plug in my numbers. Now here's a common error I see students make. They want to take the 70 squared and they add 40 squared, and then they want to subtract 2 times 70 times 40. Well, you can't do that. Order of operations says you can add these together, move these to the other side, and then we can solve for cosine of A. So I'm going to do that. So 70 squared plus 40 squared equals 6,500. 90 squared is 8,100. I believe this is 5,600 times cosine of A. So I'm going to subtract. Let me make sure about these numbers. Right, 8,100. 70 times 40 times 2. Let's just be careful I'm not making any mistakes. 4,900. And make sure, once again, let's make sure I'm using the correct equation. I don't want to make a mistake and have to. Okay. So if I subtract 6,500 from both sides, I should get 1,600 equals negative 5,600 times the cosine of A. I'm a little worried about this, but let me continue on. If it's wrong, I'll have to go back and try to figure out. So now to get cosine of A, I'll divide both sides by negative 5,600. And I'm not feeling good about this, but that happens sometimes. This is a good example of, seems to be okay. Maybe my fears, I was worried about this being a negative number, but anyways, so this right here, 1,600 divided by negative 5,600 is negative 0.2857. So angle A is the inverse cosine of negative 0.2857, which is 106.6 degrees. So now, let me go find angle B. Once again, I'm going to use the law of cosines again. Some people might want to jump and use the law of sines, which you can do, but there's danger. Let me just quickly explain that. If you choose at this point to use the law of sines to find angle B, actually, let me quickly explain. At this point, we have two things left to find, angle B or C. If I use the law of cosines, I can choose either one of these and I will get the correct answer. However, if I decide to use the law of sines, I don't have a choice. I have to find the angle across from the shorter side. So you look at B and C, side B is 70, side B is 40. Side B is 70, side C is 40. If I choose to use the law of sines, I have to choose angle C next. If I use the law of sines now to find angle B, it would be incorrect. So my message is, if you don't want to have to remember that special rule, just use law of cosines and it's going to work. Law of cosines, you can find either angle B or angle C. It doesn't matter what the order is. If you decide to use law of sines, then you have to pick the right angle and you have to remember the rule. So I'm just going to use law of cosines. So that's one less thing for me to have to remember. So here's the law of cosines to find angle B. So once again, plug in the numbers where they belong. So this is like 4,900 equals 8,100 plus 1,600. 9,700, this is 36, 7,200. If I subtract 9,700, should be negative 4,800 equals negative 7,200 times cosine of B. So if I divide both sides by 7,200, it's 0.6667. Therefore, B is the inverse cosine of 0.6667, which equals 48.2 degrees. So here's angle A, here's angle B. Now angle C, of course, we can just get by taking 180 degrees minus 106.6 degrees minus 48.2 degrees. And when you do that, you get 25.2 degrees. And there are your three angles. Problem 7. Angle C is 85 degrees. Side B is length of 9. Side C is a length of 12. So this is angle side side with matching, which means I have to use law of sines. So I'll say sine of C over side C is sine of B over side B. If I plug in all my numbers here, then I'm able to eventually find angle B. So the sine of angle B is going to be 9 over 12 times the sine 85 degrees. And that equals 0.7471. So B would be the inverse sine of 0.7471, which is going to be 48.3 degrees. Now, since I know I was given angle C, I know angle B, I can find angle A, right? 180 degrees minus 85 degrees, which is angle C, minus angle B. So this is my first triangle. So just to refresh your memory, in this kind of problem, we can have 0, 1, or 2 triangles. I definitely have one triangle. In a minute, I'm going to check and see if I have a second triangle. Oh, it should be probably 46.7 degrees. Now, the last thing I need to find is side A. So I'll say sine of A over A is sine of B over B. Angle A is 46.7 degrees over side A. Angle B is 48.3 degrees over. So side A is going to be 9 times sine of 46.7 degrees. So try to be careful. As I've been doing these problems, I've already made a couple mistakes getting my fractions upside down. So this is going to be 8.76, or I guess I said 8.8. So there is definitely triangle 1. Is there a second triangle? So once again, what you do is the very first thing I did on my first triangle was to find angle B. If there's a second triangle, there's going to be a different angle B. And what you do is this new angle B will be 180 degrees minus my first triangle, angle B. So therefore, if there is a second triangle, angle B is going to be 131.7 degrees. I don't know for sure that's a second triangle. The next step will let me know for sure. So I'm given angle C. I have a new angle B. So now my new angle A is going to be 180 minus angle C, which is 85 degrees, minus my new angle B. So then it's actually negative 36.7 degrees. All right, for triangles, we can't have a negative angle. So at this point, I say there is no second triangle. So all there is one triangle. When I'm ever working, I don't know if there's 2 triangles or not. I have to check. And once I start figuring out the information for the second triangle, when I hit a negative angle, I could stop and say, there's no second triangle. All right. I think now there were 2 more problems on the test review, but actually I don't think it's anything new or different than what we've already done. Just so you see, I think angle 8, angle side, and these are non-matching. So my first step would be to use the law of cosines. But I think I've already done a problem like that. I think problem 3 was that same kind of problem. So it's just the numbers are different. And then problem 9 is side, which I just did a problem like that in problem 6. So since there's nothing really new involved here, it's just more practice, I'm going to skip over those and keep going on to the next problems. So while I've got this up here, we'll just look at problem 10. So now we're dealing with vectors. So you see on this, bold letters indicate vectors. Of course, typically when we work out problems by hand, we draw the little half arrow on top. So we've got 2 vectors, vector A, vector B, and then they want us to do a bunch of things. They want us to add the vectors, subtract the vectors, 2A plus 3B, 3A minus 4B, and then find some magnitudes. So let me just write down these vectors on a separate piece of paper, and then we'll go through these one at a time. So number 10, so vector A, so that's how we write vectors. We're sort of writing by hand, is -3, 4. So it's almost like the X part is -3, the Y part is 4. B, vector B is 5, 2. Now the first thing they ask for is they want you to add the 2 vectors together. It's pretty straightforward, right? Adding vectors, you add the X parts. -3 plus 5 is 2. And then you add the Y parts, 4 plus 2 is 6. So A plus B is simply 2, 6. Next, they ask us to do vector A minus vector B. Same idea, except we're subtracting. So vector A, the X part, subtract the X part of vector B. So -3 minus 5 is -8. And then 4 minus 2 is 2. Now the next one is 2 times vector A plus 3 times vector B. So what you do is 2 times vector A means you take 2 and you multiply both the X and the Y part by 2. So 2 times this means really this vector is going to now become -6, 8. And then 3 times the B vector means 15, 6. Now you add those together, -6 plus 15 would be 9. And 8 plus 6. So it should be 9, vector 9, 14. And then the next one is similar. They ask you to do 3 times vector A minus 4 times vector B. So 3 times vector A would be -9. 12. And then actually I'm going to subtract 4 times vector B, which should be 20, and then 8. So -9 minus 20 minus 29, and the 12 minus 8 is 4. All right, pretty straightforward. The last two things they asked you to find the magnitude of A and the magnitude of B. Now the formulas for the magnitudes are you simply take the x part and you square it, and then you add the y part squared, and then you take the square root of the whole thing. So for A, magnitude of A, I'm gonna take the square root of -3 squared. There's the x part. The y part is 4 squared. This is 9 plus 16. So actually the magnitude for vector A is 5. For vector B, x part squared is 5 plus the y part squared is 2. 25 plus 4. I'll just leave this as an exact answer. This does not simplify, so the magnitude of vector B is square root of 29. All right. Let's just look at number 11, and we can figure it out. Write the vector u in the form of ai plus bj, where the magnitude of u is 7 and the angle is 85. So with vectors, right? Oftentimes, I mean, you can write a vector. One of the ways you can write vectors is ai plus bj. Another way you can write vectors is magnitude direction. You need to be able to switch back and forth. So here they give us magnitude direction, and they want us to rewrite this vector in ij form. So for problem 11, this vector u, they tell us the magnitude of vector u is 7. And they tell us the angle. Now, the one thing I'm going to do, and I strongly encourage you to do it, it's very simple, but it really helps you to make sure you don't make mistakes, is a lot of times it helps to sort of make a rough sketch of a vector so that when I do the conversion, I can check and make sure I haven't made any math errors. Normally, you always sort of go find your angle. So 85, 90. So always start the positive x-axis. The positive y-axis 90 degrees. So 85 is just a little bit less than the y-axis. And then you go a length of 7. So I'll just estimate. So I'll say, so I'll say this is like 85 degrees. And I'll say this is a length of 7. Now, I want to convert this to ij. It's very simple. We have a couple of formulas. The I part, you simply take the magnitude of the vector times the cosine of the angle. And then the j part, you take the magnitude of the vector times the sine of the angle. In this case, we will go ahead and get some numbers here. Make sure my calculator's in degree mode. So 85 cosine times 7 equals 0.6 I, and then 85, the sine times 7 equals 6.97. If I round to 1 decimal place. So does this make sense when I go back and look at this? So I'm saying when you graph this, like the x part, like x is 0.6. So x is just, right here, pretty small. And then j is 7. Of course, j is like the y, so it's up here. That makes sense. I could see this being 7 and this being like 0.6. Looks probably like it's correct. All right. Hopefully not too difficult. Let's go to what problem 12 is. Okay, so what they do now, they sort of flip the script. Here they gave us problem 11, they gave us magnitude direction for a vector and had us convert to ij. Now they're going to give us this vector v and ij, and they want us to convert it to magnitude and direction. Now, I'll give you a little heads up that what we're going to do next, there's 2 parts to it. One part is very simple plug and chug, but the second part can get tricky and you have to think and know what you're doing. So here's the vector we're given, vector v, which is negative 8i plus 6j. I'm going to make a quick sketch of that. So negative 8i means negative 8 in the x direction. So 1, 2, 3, 4, 5, 6, 7, 8. And 6j means 6 in the y direction. 1, 2, 3, 4, 5, 6. So negative 8, 6 is about right here. So if this is vector v, this distance here is going to be the magnitude of vector v. And then this is going to be my angle. Let's do the magnitude first. The formula, we just did this a few minutes ago. The formula for the magnitude of a vector is you take the x or the I part and you square it. And you add to it the j or the y part and you square it. 64 plus 36, that's nice. So actually it's like the magnitude of the vector is 10. Nice number. And what's the angle? So the formula for the angle, now this is the tricky part. Because when you do this initial calculation, your initial answer is oftentimes not the correct answer. As a matter of fact, here's what I'll say. If your initial vector is in quadrants 2, 3, or 4, when you do this calculation will not be your final answer. You need to do the calculation to determine the final answer, but it will not be the final answer. If you're in quadrant 1, you do this calculation and you're done. But if you're any place else but quadrant 1, you have to do some extra work after this. And the key is whenever they want a vector magnitude direction, they always want the angle to be positive. Even if you're down here in the 3rd or 4th quadrants, they still want the positive angle. And you'll see that becomes an issue sometimes. Well, let's just see what happens, and I can explain what you have to do to get the correct final answer. So the y part, which is like the j, is 6. And the x part, which is like the I part, is minus 8. So this is like negative 3/4 or negative 0.75. And I take the inverse tangent, and the answer in degrees is negative 36.9 degrees. Now, if you were to go to our little sketch and sort of imagine where negative 36.9 degrees. Now, negative degrees means you start the x-axis, positive x-axis, and you go clockwise. So negative angles, you go this way. As it turns out, negative 36.9 degrees is going to be sort of on this same line as it turns out. So obviously, this is not my answer. This is not the angle. They want the angle to be a positive number. But the thing is, this becomes like a reference angle. And by that, I mean, this angle here is actually the same as this angle here, the same magnitude. So by knowing that, what I can do to determine my angle, I can take 180. In other words, I can go all the way across, that's 180, and then subtract 36.9, and then that's going to actually leave my angle theta. So I'm going to call this theta prime, because when I actually did this calculation, this wasn't really the theta I'm looking for. So this is like theta prime. The theta I'm looking for, I realize I can take 180 minus 36.9 degrees. So then 180 minus 36.9, 143.1 degrees. So there's your angle, and there's your magnitude. So, just tell you now, oftentimes finding the angle can be the tricky part. The formula does not automatically give you a final answer. All right, let's keep going. See what we have next. So number 12, or actually number 13. We're about finished with the first page here. All right, here's a fun problem. Two forces are acting at the point P. The first force vector is 20 pounds at south 17 degrees west, while the second force is 50 pounds at north 82 degrees west. Find the magnitude and direction of the resultant vector. So this is basically where we have two vectors. In this case, they're force vectors. So you can almost think that we're going to look at a point, the point right in the middle of our graph. And we've got these two force vectors pushing at that point. And we need to see what happens when they both push on that point. So let me write down the information and do a little sketch and talk about it. So I'm going to actually call, they don't really label them, but they say the first force vector, so I'll call it F1. And actually they give me magnitude and direction. So they say the magnitude of force 1 is 20 pounds. You may not realize it. You probably think of pounds as just something you weigh, but pound in the world of science and physics is actually a force. So magnitude of the force on vector is 20 pounds. And the direction, which we'll talk about this in a minute, they do this thing south 17 degrees west. I like to call these sort of compass directions because it's like using a compass, north, south, east, and west. So the second vector, its magnitude they say is 50 pounds. So the first thing you notice is this second force vector is a lot stronger. It's over twice as strong as the first force vector. And then its direction is north 82 degrees west. Let me draw a sketch with these vectors, and then we'll talk about what we're supposed to try and find, and then we'll discuss how we're going to do it. Really, if you don't sketch out these problems, then you're just asking for trouble. So take a minute and sketch it out. Now, first I need to do is figure out, whenever I sketch a vector, I always figure out the angle or the direction first. So what does this mean? South, 17 degrees west. Normally, we label these axes just sort of X and Y. But when you have compass directions, the way we define it is up is always north, down is south. If you go to the right, that's east, and to the left is west. It's like reading a map. That's just how we lay out maps and stuff. So this direction means go in the southerly direction, the pure south direction. So we're going straight down, and then go 17 degrees toward the west. So straight down, and then I'm going to go 17 degrees toward the west. Now, when I draw the vector, the length of my vector, I'm going to sort of think of that as being magnitude of 20. So whatever the length of my line is, that represents like 20. So the angle's about here, and maybe I'll call 20 like this. So this length is 20. This angle here is 17 degrees. So this is the F1 vector. Now F2, the direction, you start north, and then they say 82 degrees west. Well, if I'm north, pure west would be 90 degrees, but I'm going 82, so I'm a little above going straight west. But when I draw my vector, it's got to be 50. It's got to be over twice as long as this one. So maybe I will imagine it maybe looks like this. So here's the force 2 vector. So once again, the length of this is going to be 50. So that's the magnitude. And this angle here is actually going to be 8 degrees, right? If this is 82, this is 8 in here. So what happens is you can think of putting a little block here or something here at the origin, and you've got this first force pushing it down, I'd like with a force of 20. Then you got the second force pushing it really to the left with a force of like 50. So the second force is going to sort of dominate, but this first force still has an effect. Matter of fact, when you think about it, what we're actually going to do, they're really asking for the resultant vector. I'll call it F, and the resultant vector is really just adding the two force vectors together. That's what we're really doing. Since both of these are pushing on the same point here, it's like these forces are being added together. So the question is, what's it going to look like when you add these together? Well, once again, the second force should dominate, but this first force still makes an impact. My guess is it might be sort of, it's just a hunch, maybe a little bit like this. This is what I would expect. So the final vector mainly heads out toward the west, but it's going to be pushed down a little bit by this first vector. So that's my guesstimate of what I think the resultant vector sort of looks like. Now I'm going to see when I do the problem, when I get done, whether it looks like it makes sense or not. But let me do this. One of the first issues is we have compass directions, but in order to start working on this problem, I need to know the actual angle theta from the x-axis. So here is my actual angle for force 1. Hopefully you can see from here to here is 82 degrees. So 90 plus 82, it's actually 4. Oh, sorry. This is force vector 2. For the second force vector, hope you can see how this angle is 172 degrees. For the first force vector, we go all the way, this picture's getting messy, all the way to here. Now, if I go all the way straight south, that'd be 270 degrees. And I'm coming back 17 degrees. So really 270 minus 17 is like 253. So I believe this theta 1 is going to be like 253 degrees. So it's a little bit of extra work because that gave us our direction and what I call compass directions, but we can't use these angles when we start doing some calculations. We have to figure out the standard angles, which means you start at the x-axis. So for that first force vector, our angle is 253. For the second force vector, the angle is 172. So now let's add the vectors together. Well, the problem is when vectors are in magnitude and direction format, I cannot add these when they're this format. I'm not able to do that. However, we can even look at problems we did a few minutes ago. Remember problem 10? They gave me two vectors. They were in this form, which is similar, it's really just the same as IJ, right? So when your vectors look like this, or when the vectors are in IJ form, we can add vectors together very easily, right? If these vectors are in IJ form and I want to add together, -3 plus 5 is 2, 4 plus 2 is 6. So really what I'm going to have to do here, in their current state, I cannot add these force vectors together. However, if I take each force vector one at a time and rewrite it, in other words, this is magnitude, direction. If I can take force 1 and rewrite it as an IJ vector, and then take force 2 and rewrite it as an IJ vector, then when they're IJ vectors, I can add them together. So that's what has to happen. So I'm going to take force 1 and I'm going to write it as an IJ vector. I'll go way down here. So remember, when you have a vector magnitude direction, here's my angle. To convert it to IJ, you take the magnitude, which is 20 times the cosine of the angle, 253 degrees. That's going to be my I part. My J part is my magnitude times the sine, 253 degrees. That's the J part. So in a minute, I'll do this calculation here and we'll have this force 1 vector in the form of IJ. Just do the same thing for the second force vector. Magnitude is 50. The angle is 172 degrees. There's the I part. Plus 50 times the sine of 172. There's the J part. So I got my calculator and do these 4 calculations. So 253 cosine times 20 negative 5.8 I. Now in a minute, we're going to look at these vectors and see if these numbers make sense. And then 253 sine times 20 negative 19.1. Now if I go to force one vector in terms of ij, this does make sense. Once again, I is like the x, j is like the y. So is it like x of negative 5.8, almost negative 6, and then the y of like negative 19. So here it is. So you can imagine if this distance is negative 5.8 and this distance is negative 19, looks reasonable. Now my second force vector is 172 cosine times the magnitude is 50, negative 49.5 I. And then 172 times the sine times 50, 6.95, so it's like 7.0J. The second force vector look like it makes sense. It's like negative 50, around negative 50 I. So way out here in the I, and then a little bit up in the J, 7. Yep. So now that I've written the 2 force vectors as ij, now I can actually add these together. So I add the I part. (5.8) plus 49.5 is negative 55.3 I. Here now, be careful because it's a negative 19.1 plus 7. So negative 12.1 J. Now what's interesting is, let's just go see when I made my initial guess as to where the resultant vector might be. Let's see if this sort of lines up. So it says negative 55 and then negative 12. So negative 55, negative 12. I think it's in the ballpark. So theoretically, we now have the resultant vector. But the problem is, whenever they give you a problem like this, whatever form the problem starts out in, rule of thumb is that's how they want the answer. So if I'm going to add these 2 vectors together, they want the answer to be the magnitude of the resultant force vector and then the direction. And they even want the direction to be compass directions. So although I've added the vectors together, now what I have to do is take this force vector, my resultant force vector, I need to convert it back to magnitude direction. And once I do that, I have to also then work some more on my compass directions. So basically, this is the I part or the X part and the J part or the Y part. So the magnitude of my force vector is just that X squared plus Y squared. So negative 55.3, that whole thing squared, plus negative 12.1 squared. That's their problem for the calculator. So 55.3 squared plus 12.1 squared equals square root. Negative 56, oh, just 56.6, sorry. Seems reasonable. This is like 56 long. And what's the angle? Now, the angle is always the tricky part. And honestly, because I know my vector is the second quadrant, this formula is not going to give me directly my answer. Matter of fact, maybe I'll even start. So I know that. I'll call this theta prime. So y or my j part's negative 12.1, and the x part or the I part's negative 55.3. So first of all, the numbers are going to be positive. So it's going to be 12.1 divided by 55.3. It's like 0.219. Inverse tangent. 12.3. 12.3 degrees is maybe right here. My resultant angle is right there. So hopefully you can see, or no, it's not, it's right. It's right there. But once again, this is a reference angle, meaning this angle, 12.3, is the same as this angle right here. So therefore, if I want to get my resultant angle, I've got to take 180 plus 12.3. So it's 192.3 degrees. Now it may feel like you're done, but you're not quite done yet, because we should give them the final answer in these compass directions. So just to see, 192.3 means, looks like this, where this right here is 12.3 degrees. Now, when you do compass directions, you've got to choose north or south, whichever one you're closest to. This is closest to the south. So I've got to give this direction to south and then this many degrees to the west. So I've got to take 90 minus 12.3. At this angle is 77.7 degrees. So actually, in terms of compass directions, it's going to be south 77.7 degrees west. So there's the direction. And there's the magnitude. All right. It's a lot of work. Pretty involved problem. All right. Let me take a break, and we got a few more vector problems with dot product and then polar coordinates, then we'll be done. So we'll stop now and pick it up with question 14.